previously, we've seen that side-side angle, where the angle is not included, is not a triangle congruence postulate. Let me review that first before we get into hypotenuse leg, which is what this lecture is on. Here we have a fixed angle, and the angle is non-included. And depending upon the lengths and the angle, you can set up two different triangles that both work. And so the fact that these both have the same side-side angle triplet, but they're not the same triangle, indicate that SSA does not work because you want to be able to just only get one triangle. So in general, side-side angle cannot be thought of as a congruence postulate. However, if we change a couple things, in particular, if we make this a right angle, there's other ways to do this, but what we're going to talk about, if we make this a right angle, and let's increase this, well, now what we can do, there are ways, now with a right angle there, we can make this a single triangle. So at this point, there's no other way to make these things match up to get more than that one triangle. The only way to do it is to get them to match up there so we have the same triangle. So what we see is that for a right triangle, well, the rules, so to speak, are a little bit different, and that is summarized here. Right triangles congruent by hypotenuse leg. So it may only seem like there's two things here, hypotenuse leg as opposed to three, but really there are three things because you have this right angle too. So it's a side-side angle where this angle, this non-included angle, must be a right angle. And so the first side is the hypotenuse, then the leg, and then the angle. It could be this leg too, so side angle. So this is sort of a special case for SSA, which does work, and we call it hypotenuse leg because it is specifically for right triangles. So now a few examples. Well, here's a proof. We'll take a look at a proof, and then we'll break it down a little bit differently. Given angle P and angle R are right angles, here's our figure. They're already drawn in. PS is congruent to QR. That's already labeled. Prove that triangle PQS is congruent to triangle RSQ. So first, we would write all the given. So I would just write all this down here. That's given, and label the figure accordingly. Already it is. Now, HL is only going to work if I have right triangles, so I've got to establish that fact. So I say triangle PQS and triangle RSQ are right triangles by the definition of a right triangle because, well, they have right angles, and any triangle with a right angle is a right triangle. So now I've got that set up. So then SQ is congruent to SQ. So now I have, for each of these triangles, it's a right triangle. I've got a hypotenuse, leg, so now I'm able to say that the two triangles are congruent by HL. You don't say SSA, you specifically say HL, hypotenuse, leg, and there's your right angle. Now this is looking at the same type of thing, but just sort of the rudimentary parts of a proof. What more would you need in order to show that each pair of triangles is congruent by HL? So here I've got the right angles, so they're right triangles. I've got a leg, but I would also have to show that the hypotenuses were the same. So the additional information I would need is that VW is congruent to RS. That's the part of information I would have to add on. Over here, I have these two sides the same, but I haven't established the right triangle, so I would need to have that angle C and angle F are right angles. Theoretically, I could say angle A and angle D instead. Those could be the right angles because those are not included, but according to the way the figure looks, it's pretty clear they're looking for C and F. You couldn't use B and E because those are included angles. That would be SAS. Now for this one, we know that this side's equal to itself, and so we have hypotenuse, leg, but you can't use HL until you establish you've got the right triangles, so you'd have to have angle D and angle F are right angles. Again, you could, I suppose, use a different angle pair, angles DCE and angle, actually no, non-included, so this angle DEC and angle FCE, but that really wouldn't make sense according to how the figure looks. And then over here, HJ is congruent to itself, so the additional information for hypotenuse leg with hypotenuse leg would be this angle parent here, so angle GHJ and angle JHI are right angles. And so everything we would have learned before about what we can do with right triangles also, with triangle congruence also applies here. This is just one other way, one additional way to show two triangles are congruent using this principle of HL.